Hey, welcome back, everybody. This is the answers to the closure problems for Chapter 4. And first off, I want to remind you, you do all these problems in the book. It's on page 204, 205. You flip over to page 207, and boom, all the answers are there for you. It says, hey, you need help? Go look at these sections. Look at these specific problems. Maybe go look at another video. If you're totally stuck, you started your homework late, and you weren't able to go see your teacher for help, great thing to do, right? You have options, okay? Don't ever say, oh, I can't do it, and have that defeatist, I can't attitude. Always say, I can, right? Because whether you say you can or whether you say you can't, you're going to be right, all right? So I'll remind you on all that. That first group of problems, you had to put a whole bunch of different numbers on a number line, and those numbers were written as fractions, decimals, and percent. What does that remind me of? Reminds me of the whole idea when we did those portions webs, right? And you want to know how to change a fraction to a decimal, or a decimal to percent, or percent to a fraction, or percent to decimal, right? You want to be able to interchange them all. So you know which ones are bigger, and you sort of have an idea of how one relates to another, right? It's bigger, smaller, it's way bigger, it's way smaller. I said yesterday when you started this that I think that changing them all to decimals was the easiest way, right, to compare them all. So that 4/5, okay, we divided, that's 0.8. I'm going to go ahead and that's 0.5, that's one whole. So maybe 6, 7, 8, 9. I'm going to say 0.8 goes right there. Okay. Now, 3 thousandths, that's not 3.0. That's not 0.3. If I wanted to compare 3 thousandths to 0.3, remember you stack them and line up the decimal. 3 is here. And if I want to bring out zeros, I'm allowed to add zeros. This is like comparing 300 to 3. 300 is way bigger. 3 thousandths is pretty close to 0, as close as I can get. What's it called when you get as close as you can, right? Without touching your finger, milli. That's like a millimeter away from that 0. 0.003, 3,000. That's going to be really, really tiny. Okay, 30%. 30%, however, is the same as 30 per 100. Okay, so that's the same as 0.3. So that's the 30%. It's going to be right on this line. Okay, next one is 7/6. That is more than one whole. So we already have that. That's 1 1/6. 75 hundredths. That is like 75 cents out of a dollar. This is 0.7. This is 0.8. If you add zeros, that's 70 hundredths and 80 hundredths. Where's 75 hundredths? Right here. Okay, so I'm going to put the line there and put the 0.75 so I know where it is. Okay. All right, next one, 3/7. What's that? As a decimal, I'm going to divide the bottom into the top. Okay, it won't fit. You add a decimal, right? It goes in 4 times. That's 28. Now, I'm estimating where this goes, right? 7 goes into 14 twice. That's 14. Add another 0. Now it's going to go in 8 times. All right, now add another 0. Now I'm not going to keep on going with this, okay? I'm going to go ahead and stop here and say that's about 429 thousandths. I'm going to round to that spot. That's a 5, so it goes up. So more than 0.4, that's 400 thousandths. Less than that, not quite halfway. I'm going to say it's about right here and call 3/7 that. Okay, 1/3. When I divide the bottom into the top, some of you know that's 0.3 with a line over 0.3333. So more than 30%, but not too much. Put 1/3 there. And 112, 112 goes right on that line. Okay, all right. The next one, find 7m plus 9 if m equals 2. I already figured out that's 7. I remember you substitute. 7 times 2 is 14. 14 and 9 more is 23. Michael Jordan is happy. You got his number. Okay, how about A times B? If A equals 10 and B equals 4, I go substitute. 10, 4, good buddy. 10 times 4, 40. CB talk. Have no idea what that means. Rubber ducky, rubber ducky. Breaker 19. We got Smokey in the air. All right. Yeah. Your teacher's old. X plus X plus X plus X. That's the same as 4 times X plus 9. Right? And now they're saying pretend X is 20. So 420, 4 times 20 plus 9. That's 80 plus 9. This line segment is 89. Okay. Now for B, I got JJK 65, JJK 65. So that's the same as 2 times J plus K. And I'm going to put the 6 and 5 together and call that 11. Now, if J is 10, I got 2 times 10. That's 20. K is 7. 20 plus 7 plus 11. That's 28 and 11. 38. Okay. We already did the first one on the next one. The next one is 6 plus 0. That's easy. That's 6. And negative 2 plus 8. I owe 2, but I have 8. I'm going to pay the 2. I'm still going to have how much left? 6. All right. Cruising through this. We already figured out I was adding 1 dot this way, 1 dot that way, right? This is 2 tall. Now it's 3. Now it's 4. This is 3 wide. Now it's 4. Now it's 5. So I'm going up by 2 dots each time. If I'm going backwards, I'm going to go down 1 and over 1. So all I have for 0 is these 2, right? Because I shrunk it down. For 4, now I'm going to have 5 up, right? And I'm going to have 6 going to the right. That's 1, right? And that's a total of, wait a minute. Oh, yeah. 5. I would say 5 plus 6 is 11. This is going to be 10. It's because of this dot here. I counted it going up and I counted it going across. Okay. Can't count it twice. Okay. Now, what's 7 going to be? Well, this is going to be 12. This is going to be 14. This is going to be 16 dots. But, right, if it was the second figure, I got the 4 going to the bottom. All right. First figure, I got 3. So the 7th figure, I'm going to have 9 on the bottom. Right. Now the third figure went 4 up. The second figure went 3 up. The first figure. So it's 1 more than the figure, right? So it's going to go 8 up the side. Now 8 and 9 is 17, but I'm counting that twice. So that's why there's 16 dots. Okay. All right. Right triangle. Now it's going to be 5 tall because it's 2.5 times bigger, right? 2.5 times 2. 4.5 times 4 times 2.5 ends up being 10. Okay, same triangle. Okay, because the proportion's the same. All right, and 15, that's going to be much bigger, right? For every 2, now it's 15. For the fourth 3, now for every 3, it becomes a 4. That gets a little bigger. Right? Now for 5, 6, now for every 6 turns into a 5, it gets a little smaller. And for 12, 12s, every 12 is now a 12. It's the same. Okay? All right, last one. We already figured out the 2 dots. Now we want to make a rectangle. Now that's okay. I'm going to say let's put this here and this here. That works. Right? Made a rectangle. Okay, now did I make the right kind? Let's see. Horizontal length. Horizontal, that means it's flat. Okay, and they want to know the other vertices. Well, this one, now it's over 4 and only up 3. and it's still over -2, but now it's up 5. Last one, they want to find out how long this is. And how long this is this 2 plus this 4. So it's 2 plus 4 is 6, but they want you to write an absolute value expression. Well, how far did I go over? I went -2. But the length of that is the absolute value of -2. How far did I go over that way? I went 4. The length of that is the absolute value. So the absolute value of -2 plus the absolute value of 4, that's how I got the 2 plus 4 to say this rectangle is 6 wide. Okay? Hopefully that made sense to you, and hopefully this helped you prepare for the test. I'm actually, instead of releasing this in the morning after this is due, I'm going to release this afternoon. So you'll have these answers before the tomorrow morning, before you go take that test. Okay? All right.